let me repeat. In the basic concepts of organic chemistry, we'll be explaining about the unique nature of carbon. Followed by that, I'll be explaining about the nomenclature part of it and some of the basic principles with regard to organic chemistry. When we talk about this carbon, it has the tetravalency, that is, it has got 4 valency. Valency means binding tendency, that is the number of electrons available in the outermost shell. Is 4. For example, let us work out the electronic configuration of carbon. So here we have got the atomic number 6. So 1s2, 2s2 and 2p2. So let us consider the outermost one, that is here second shell. So we have 4 electrons, that is, it can be represented by a box like this. So this is S, this is P. So 2s2 means you have got 2 electrons and here 2 electrons in p orbital, that is 2p2 and 2s2. Okay, so that is why we call the carbon has a valency 4. It means that is it can combine with 4 another elements or electrons of other elements, and it can combine with hydrogen, it can combine with oxygen or halogen, nitrogen and sulfur, etc. So if it is based on carbon and hydrogen, we call it a hydrocarbon. Okay, take down hydrocarbon. And this hydrocarbon essentially can be divided into, that is, open chain and a closed one, that is a ring based one, ring structures. The open chain hydrocarbon, that is, they are called acyclic, and ring based means cyclic. And this is also further divided into, that is, a homocyclic, heterocyclic. Homo means the same, that is, that cycle structure is based on the same ring, that is made up of carbon, whereas there will be an hetero, a different atom present in the ring. So that represents heterocyclic. Now let me talk about this acyclic. And this acyclic, here we have alkanes on the one side, on the other side we have alkenes and alkynes. Alkanes means they come under the saturated category. It's called saturated hydrocarbon. And these two are called unsaturated hydrocarbon. Saturated means satisfied with the single bond, whereas unsaturated means it is not satisfied with the single bond. Instead, they will be having double bond or triple bond. So alkene will be having double bond, alkynes will be having triple bond. And this alkane, let us refer to alkane. They are also known as paraffins. And they are generally represented as a CnH2n plus 2 by the general formula, where n represents the number of carbon atom. You should remember, if you have got 1 carbon, it should be called meth. If you have got 2 carbon, it should be called eth. 3 carbon prop, 4 carbon bute, 5 carbon pent, 6 carbon hex, 7 carbon hept or sept, and 8 carbon oct, 9 carbon non, 10 carbon dec. And alkanes have the general suffix, that is A, N, E. This is the general suffix. Suffix is the set of letters added at the end. Prefix is the one which is added before the word. So here meth is the prefix. So let me combine this meth. Meth means with a single carbon. So an alkane with a single carbon. So meth plus ane, that gives methane. It's not a chemical reaction. It is only a schematic way of representing or deriving the name. So methane. So meth means it has got one carbon. So we can apply the formula of CnH2n plus 2. So work out this C1H2 of 1 plus 2, that is equal to CH4, is it not? So methane, its molecular formula is CH4. And it has got tetrahedral structure. Tetrahedral structure means it is represented by TH. Okay. You just draw a cube and keep at the center of the cube one carbon. Then you can fix hydrogen at one of the vertices here and other here, other here, other here. Okay, hydrogen, 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 hydrogen. It is something like a camera, a tripod. Okay, so the bond angle between these CH will be 109 degree, 28 minutes. Roughly you can say 109.5 degree. You know very well 0.5 degree means that is 30 minutes. That is 1 degree is equal to 60 minutes. 0.5 degree means 30 minutes. So exactly 28 minutes. So roughly 109.5 degree. Okay. Excuse me. And then they have, it can be simply represented like this: CH4, H, 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 H. Okay. You have CH sigma bond, sigma bond, sigma bond, sigma bond, and there are 4 CH sigma bond. When I introduce the term sigma bond, you will definitely ask me what sigma bond is. It is because of the linear overlapping of orbitals. Okay. Whereas pi bond is due to sidewise overlapping of p orbital like this. Now let us move to, and in fact alkanes have only sigma bond. It doesn't have any pi bond. Let us move to alkene. Alkenes have double bond, C double bond C. It is an unsaturated hydrocarbon. It has the general formula CnH2n. Ethene is the starting compound. So eth means 2 carbon. Therefore you can put C2, and what is the general formula? CnH2n. So 4, 2 into 2, 4. So it can be represented as CH2 double bond CH2. It can further be represented like this: H double bond CH. Where you can find, you have CH sigma bond, sigma bond, sigma bond, 4 CH sigma bond, and 1 CC sigma bond, and 1 CC pi bond. Then regarding alkyne, they have the general formula CnH2n minus 2. the starting compound is C2H2, that is C H triple bond CH, and it can be represented as HC triple bond CH. And here you have one sigma bond and two pi bond, and one sigma bond CH, and here also one sigma bond. So you have CH sigma bond 2, CC sigma bond 1, and CC pi bond 2. Got it? Together you can call it 3 sigma bond and 2 pi bond here. So this is alkyne. Now let me put together alkane, alkene, alkyne. Alkane, alkene, alkyne. What is the starting compound here? Methane. And ane is the suffix. And here there is no methane, it's not stable. There is no methane, it's not stable. And you have ethane. Here ethene. And this one ethyne. We already know eth means 2. So it is, we can write down the general, formula also. This is CH4, and this is C2H4, H6. What about this? The general formula for this one is CnH2n plus 2, and this is CnH2n, and this one is CnH2n minus 2. So you have ethene and ethane. Ethene is C2H4, ethyne C2H2, and here prop means 3 carbon atoms. You can compare with this. You have got meth finished, eth finished. Now prop means 3 carbon atom. So propane. And what about its molecular formula? C3. Work out the formulas. 2 3s are 6 plus 2 8. So C3H8. Here propene. Propene. So we have C3H6. Is it not? What about propine? C3, and that is 2 3s are 6 minus 2 4. So H4. Similarly, butane. Okay. Now we have C4H10, and here butene, and this one C4H8. And what about this? Butane. That is C4H, 2 4s are 8 minus 2 6, C4H6. Okay. And pentane. So C6H, C5H, 5 2s are 10 plus 2 12. And here pentene, and this one C5H, how much? 10. This is pentine. So C5H, 2 5s are 10 minus 2 8. So C5H8. Likewise you can proceed. Okay. If you got any doubt, you can ask me. Shall I proceed? Now let me introduce another set of groups, that is alkyl group. Take down alkyl group. It's not a compound, it's only a group. For example, you have CH4. Subtract one hydrogen, so you will get CH3. That is called methyl group. CH3, methyl group. And this can be represented as CnH2n plus 1. That is the general formula, because we have subtracted one hydrogen. So CnH2n, instead of plus 2, we put plus 1. And what about if it is ethane, ethyl, is it not? C2H5. This is ethyl group. And what is the next one? C3H7, propyl group. Okay. And you should also note down C, if it is like this. Okay. So 3 plus 3, 6 plus 1, 7. If it is branched evenly like this, then it can be called isopropyl. And you can take CH3, CH3, CH, CH2. This is called isobutyl. Okay, 1, 2, 3, 4. Buta. Iso means similarly branched. And if it is linearly available like CH3, CH2 without branching, then it's called normal butyl. N-butyl group. And if it is like CH3, CH3, CH3 and like this, then 1, 2, 3, 4, this is called tertiary butyl. Group. And this is also called, is also known as secondary propyl group. But this is not secondary. This isobutyl is not secondary. Okay, it is still primary only. I will explain how this primary, secondary, tertiary comes in the next session. Next one. I noted down. Shall I proceed? Next. We have another group like this. CH3, 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 CH2. Okay, this group is called 1, 2, 3, 4, 5, neopentyl group. Now let me introduce the functional group. Functional group is something unique. It may have hydroxyl group in the case of alcohol, and it can also be having alcohol in the case of enol. There is a difference between alcohol and enol. I'll tell you later. And this is a halogen. So halo group means that is fluorine, chlorine, bromine, iodine, etc. And this can have that is a CHO group, that is called aldehyde. And you have carboxylic acid, and you can have a compound, group like this. This is called keto group or ketones. In fact, this is the hydroxy derivative, and the resulting compound is called alcohol. And functional group that they can combine with the alkyl group to form a useful product, like for instance you've got alkyl group R, and you can combine with OH, alcohol group, so you will get ROH. This is called alcohol. So this is alkyl group. And this is also represented as, instead of ROH, we can have RCH2OH also. So if it is RCH2OH, R represents including hydrogen, then CH3 alkyl group, and then C2H5 ethyl group, C3H7 propyl group, etc. If you represent like this, then it starts from R is equal to CH3, C2H5, etc. So the best way of representing alcohol is RCH2OH. So you have now RCH2OH. This is called primary alcohol. And you know that this is the functional group, and this is the alkyl group. Now let me introduce the first compound, CH3OH, which is called, that is methyl alcohol. Methyl, then alcohol. It's a trivial name. By IUPAC it should be called methanol. So you have CH3, then OH. You know this is from CH4, is it not? You called it methane. What you do is cut this E, and this is OL. Add OL so that you will get methanol. Are you will follow? So how to form the alcohol groups? For example, when you have got alkane plus OL gives, now what you are supposed to do? Drop the E, then add, then it will give alkanol. That's all. For example, let me have ethane. Drop E, add OL, then ethanol. That's it. Okay. Similarly, you have propane. Add OL, drop E, propanol. Okay. Let me consider the first compound is methanol, CH3OH. Second compound, CH3, CH2OH. So this is methanol. What about this? Ethanol, CH3, CH2, CH2OH. 1, 2, 3. Propanol, CH3, CH2, CH2, CH2OH. Butanol. So when you go on writing many number of carbon atom, you may get bored, and you want some simple representation like this kind of bond line. So better 1, 2, 3, 4, is it not? So 1, 2, 3, 4. 1, 2, 3, 4. Then put OH. So this represents butanol. That's all. So in a simple way, this can be represented. And how about this one? If I do like this, now what is this compound? 1 2 3 4 5 and then OH. So 5 means pentanol. So this is 1 pentanol. Do you understand now? This is easy way of representing the structures. Now listen, let me talk about this. Whenever you have the organic compound with its functional group, identify the functional group first. Then identify the carbon skeleton. Now number them. There are two important rules you have to follow. One is longest chain rule in IUPAC. There are many rules, but two important rules are very important. Two important rules should be followed strictly. Longest rule and lowest number rule. So longest chain rule. The chain should be as long as possible. Then lowest number. Here number means that represents substitutions. Number or position of single bond, double bond, triple bond. So lowest number rule of substitution. Now where is the substitution? In fact, this is a functional group. Okay, this is functional group and it is attached to the first carbon atom. So in this case, this is attached to first carbon atom, second carbon atom, third carbon atom, fourth carbon atom. So OH is attached to first carbon atom. So it should be called 1-butanol. Okay, or butan 1-ol. If it is attached to the second carbon atom, let us check. 1, 2, 3, 4. Butanol and OH is attached here. Now fill up with hydrogen. Ensure each carbon atom should have 4 valencies. So CH3 plus 1, 4. 1, 2, 3. So you can put H. And here 1 and 2. Here 1, put 3. So 1, 2, 3, 4. If you write like this, it becomes 3. So which substitution is feasible? Second substitution. That is the lowest number rule. According to lowest number rule, you should prefer this, not this. So it should be called 1, 2, 3, 4 butanol. That's all. You understand? 2-butanol. Suppose if it has some substitutions, let me represent like this. This represents methyl group. Now how to name it? Count the, first identify the functional group and which is the longest chain. 1, 2, 3, 4, 5. So pentane and all, pentanol. You can write down immediately pentanol. Okay, pentanol. And if it is pentanol, and what about the substitution? The substitution here is methyl group. If I put like this, it is methyl group. So in which methyl? Second position. So 2-methyl pentanol. You can also call it pentan 1-ol, but normally if it is 1, if the hydroxyl group is present in the first carbon atom, you can ignore calling it 1. If it is 2, second position means you have to insist. Okay. So what do you call this compound? 2-methyl pentanol. That's it. Or 1-pentanol. Okay. Now, if you have a compound like this, now what is the name of the compound? 1, 2, 3, 4, 5 penta. 1, 2, 3, 4, 5 penta. and it has all, so pentanol, so 3 pentanol. Okay, you can also call it by pent and 3 anol, pent 3 anol. Okay, let me introduce another compound. CH3, CH2, CH3, CH2, CO, CH2, CH3. Now what is the functional group present here? We can identify the functional group as keto group because it is CO. Let us expand it and name it, so that will be very convenient to you. So how you can expand it? CH3, CH2, C double bond O, CH2, CH3. So by trivial name it can be called, you have got ethyl group, another ethyl group, in between that a ketone. So diethyl ketone, DEK, diethyl ketone. But by IUPOC it should be called OM, alkanone. Okay, alkanone. And in fact I want to give the appropriate IUPOC names also here. Please make a note of it. Alcohol should be called alkanol. And this one should be called haloalkane. And this should be called alkanal, AL. And this should be called alkanoic acid. And this is called alkanone. Okay, now we are discussing this aspect. So 1, 2, 3, you have to include the carbon atom of the function group also, because that is directly linked. So 1, 2, 3, 4, 5, pentanone, and where is it present? Third position. So 3 pentanone. Got it? Okay. So we will have different types of alcohols also. As I already mentioned, methanol, ethanol, propanol, butanol, pentanol, all these things you know. And I would like to give some importance to the primary, secondary, tertiary alcohols. Take down alcohols. It can be classified as primary, secondary, tertiary based on the nature of the carbon chain. Let me take propyl alcohol, propanol. 1, 2, 3. So the OH is attached here, and in this case the OH is attached here. Now what is the difference between these? Here it is attached to first carbon atom, here it is attached to second carbon atom. So in this case, that is CH3, you have got one carbon atom and put 3 hydrogen to get 4 valency. 4 because carbon is tetravalent. And here CH2 and here CH2. So 1, 2, 3 propanol, 1 propanol. What about this? CH3, CH3, and here 1, 2, 3 you can put CH only. So this is 2-propanol. 2-propanol. Okay. Usually in case of alcohol, as I already mentioned, primary means you should have RCH2OH as the formula. Or CH2OH, and in this case R2CHOH secondary, and here R3COH. What is the difference among these three? Here let us consider the first one. R can be representing any alkyl group. Let me take butyl. So in this case CH3, CH2, 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 OH. What is this? Butyl alcohol. Actually, this is a functional group. The carbon atom attached to the functional group can be called alpha, and the next one is beta, next one gamma and delta. So when the alpha carbon atom has a 2 proton, it is called primary alcohol. Please make a note of it. Okay. When the alpha, what is alpha carbon atom? The carbon atom immediately joined to the OH group, immediately attached to the OH group is called alpha carbon atom. And that carbon atom, when it has 2 hydrogen atom, that is, we call it protons also. So when it has 2 protons with the hydroxyl group, then it's called primary alcohol. And when it has only 1 hydrogen, it is called secondary. When it doesn't have any hydrogen at all, then it's called tertiary. Okay? Right. Usually, as I already mentioned, CH3, C, CH3, CH2. Okay, CH. So if it is branched like this, it can be called iso. In the case of propyl alcohol, isopropyl alcohol. For example, this is CH3 isopropyl. And what about isobutyl? CH3, C, CH3, CH, CH2. This is called isobutyl. Are you able to follow? And the isopropyl is, now look at this, this is, for example, an alcohol based on isopropyl, an alcohol based on isobutyl. And we will discuss about these two. Take down this question. Isopropyl alcohol is a secondary alcohol. Whereas isobutyl alcohol is not a secondary alcohol. Why? Let me explain about this. Isopropyl means, as I already explained, it has branched structure like this: CH3, CH3, CHOH. And isobutyl means CH3, CH3, CH, CH2OH. Okay. So what they have suggested, isopropyl alcohol is a secondary alcohol, whereas isobutyl alcohol, it is not secondary alcohol. Why? That is the question. What I already suggested, the carbon atom attached to the functional group immediately. This is the functional group. So this carbon atom is alpha. Similarly, this is the functional group. This carbon atom is alpha. So when it has one hydrogen, it is secondary, is it not? That I already explained. Am I right? So here I have given RCH2OH. When it has two hydrogen, it is primary. When it has only one hydrogen, then it is secondary. When it has no hydrogen, tertiary. Okay? So we have here two hydrogen, and that is why it is primary. But what about this? It has one hydrogen only, that is why secondary. Then you may ask me, that is why and what could be the secondary butyl alcohol? The secondary butyl alcohol structure will be 1, 2, 3, 4 butyl and put OH. Now you can claim that this is secondary. Are you able to follow this? Why? Because it has CHOH group. So remember, when I say RCH2OH, this is primary. R2CHOH means secondary. R3COH means tertiary. Got it? And here, let us consider, we should be able to identify the primary, secondary, tertiary nature also. For example, CH2OH, CH2OH. This is called dihydroxy derivative. What do you call it? Dihydroxy derivative. It has two alcohol units. So it can be called a diol. And since it has two carbon atoms, so ethane diol. So 1, 2 ethane diol. Ethane diol. In this case, let us identify the type of primary or secondary or tertiary alcohol. Now OH, CH2OH, CH2OH. What about this? It is primary or secondary, this alcohol? This is CH2OH, so primary. What about this? This is also primary alcohol. Okay? Let me introduce another compound, glycerol. CH2OH, CHOH, CH2OH. So here, in this case, CH2OH is primary. This is glycerol. This is secondary. This is primary. So are you able to identify the secondary alcohol here? Because it has got only CHOH. Okay, right. And let us discuss the other aspect. Like I was discussing about alcohols, then we'll go ahead with aldehydes. That can be called alkanal, AL. That is nothing but aldehyde. What is the functional group? CHO, and the general formula RCHO. Right? Now we have, it can also be represented as CN H2N plus 1 and the CHO. Now the first compound is HCHO. That is, usually by trivial name it's called formaldehyde. Formaldehyde. That is by IUPAC methanol. So HCHO. And usually this is represented as the CHO, that is RCHO can be represented as RCHO H double bond O, like this. Okay, so ensure the valency 1, 2, 3, 4. So whenever you write a structure, you must insist the tetravalency of each carbon atom. So this is aldehyde. So HCHO, methanol, Al. The next one, CH3, CHO, that is acetaldehyde. Methanol, Al. CH3, CH2, CHO. What do you call it? And we can call by IUPOC, that will be convenient. So yet next is prop, so propanol. And CH3, CH2, CH2, CHO. 1, 2, 3, 4. So it is butanol, Al. And can you name this compound? Anyone? 1, 2, 3. And you have to include this one also, 4. Means that is butanol, the same one. Okay. And let us proceed with alkanoic acid. Which is nothing but carboxylic acid. So the carboxylic acid here is represented as RCOOH, that is RC double bond OOH. And this RCOOH here, this is the functional group. And you have to change this alkyl group starting with H. So HCOOH, what do you call it? Formic acid. Or it can be called methanoic acid. CH3COOH. It's called acetic acid or ethanoic acid. Similarly, CH3, CH2, COOH. So 1, 2, 3, propanoic acid. CH3, CH2, CH2, COOH. 1, 2, 3, 4, butanoic acid. Likewise it goes. Okay. So this acid can result anions like RCOOH that can give out H plus protons. Maybe a weak acid, but even then it can form carboxylate. This is called carboxylate anion. Of course, by releasing H plus, it behaves as an acid, carboxylic acid. And this is proton. For example, when you have HCOOH, you can have HCOO minus, H plus. What do you call it? Formate anion. Formate anion. Formic acid. Formic acid, formate anion. So by IUPOC, methanoic acid. Methanoic acid. Here methanovate. And you have acetic acid CH3COOH, it can release 1 plus H plus. It should be called CH3COO minus. So this is acetic acid, and this should be called acetate anion. Or this is 1,2-ethanoic acid, and this is called ethanoate anion. So these are all called a carboxylate. Generally, this is alkanoic acid, is it not? Carboxylic acid, general IUPAC name is alkanoic acid. Similarly, you can get alkanoate. And here, alkanoate. Alkanoic acid, alkanoate. For example, you can form some salts based on this carboxylate, or COO minus plus. You can have some potassium ion K plus, so that you can have RCOOK. So this is alkanoate, and this is potassium cation. So this should be called potassium alkanoate. For example, when you have CH3COO minus, what is this? Acetate. When it combines with the K plus or Na plus, you can take, so sodium. Always cation should be named first. So CH3COO Na. Okay, CH3COO Na. Don't read the CH3 Kuna. CH3COO Na. So here sodium acetate, and by IUPAC, what is this? Ethanoate, is it not? 1,2-ethanoate, and this is sodium ethanoate. Okay. And let us talk about the esters also. See, an alcohol can join with an acid to form ester and water. For example, you have got ROH and here RCOOH, so that hydrogen can be removed, hydroxyl can be removed here. So you have got water here, the remaining is RCOOR. In order to distinguish, you can put R prime here. For example, CH3OH, and here HCOOH. Now you can have HCOO, remove this, and water. The remaining is HCOOCH3. How to name it? You know very well about this. This is called formate. So methyl formate. Are you able to follow? Methyl formate. Okay. And by IUPAC, methanolate. Right? Let me have CH3 CH2OH plus CH3 COOH. Now what could be the compound? Remove H, remove OH and water. So the remaining is CH3 COO, and here CH2CH3. Not CH3 CH2, CH2 CH3. Through CH2 it is linked. So what is this? Ethanoate, ethyl ethanoate. Okay, ethyl ethanoate. Let me have some other salts with a divalency, trivalency. For example, I got aluminum, calcium ion, Ca2 plus I have CH3 COO minus. Then what could be the salt I am going to get? This is 2 plus, this is single minus, so put twice. So in that case CH3 COO twice and then Ca. Are able to follow? So this is called calcium acetate, or it can also be called calcium ethanoate. Okay, calcium ethanoate. Suppose if you have got aluminum 3 plus HCOO minus, what will be the compound? It has got 3 plus, you have got only 1 minus, so put 3. So HCOO 3 times and then put aluminum. So aluminum methanoate. Aluminum methanoate or aluminum formate by common name. Aluminum formate, right? And finally, let us discuss about the ketones also. They have the general functional groups CO. It can be represented by RCOR, that is R C double bond O R. We can have CH3 C double bond O CH3. This is called acetone or dimethyl ketone, DMK, dimethyl ketone. But IUPAC 1, 2, 3, propanone, 2-propanone. Okay. Similarly, can you give the structure of 2-butanone? Butanone 1, 2, 3, 4. 2-butanone double bond O and fill up with the hydrogen. That's all. Okay. C double bond O only. So this is called 2-butanol, right? You can count from here or here. If you count from here, it becomes 3. Okay, so you have to count from here, and you can draw this one also. Both are same. Both are said to be equivalent. So this is regarding ketones. So far we have discussed alkanes, with the general formula CnH2n plus 2. Then alkene with the general formula CnH2n. Alkyne with the general formula CnH2n minus 2. Then alkanol. What is alkanol? Alcohol, that is RCH2OH. And then RX, haloalkanes also. Bromomethane chloroethane, like that. Okay, so halo alkanes, that is very simple. Alkanes, then RCO, or that is alkanones, that is ketone, then RCOOH, alkanoic acid, and then RCOO, some salt like potassium, so alkanovate, that is carboxylate. And then we discuss about esters also. Okay, so you have to practice with minimum 6 numbers, at least 6 first numbers, 1 2 3 4 5, and then 6 7 8 9. So 9 into 6 compound, so you should be able to get at least 54 compounds with molecular formula, structural formula, trivial name, then IUPAC name. Okay, so with this, let us conclude this lecture.